In a Young's double slit experiment, one of the slit is wider than the other. So the amplitude of the light from one slit is double of that from the other slit. So we have two slits here. So one slit is wider than the other. So in the screen also, we obtain interference phenomenon with not exactly dark fringes. So the dark fringes will also have some brightness left. The brightest fringe obviously will the central bright, then we'll have a dark fringe and then other bright fringes. So this is how the phenomenon is going to be. The maximum intensity happens where both the amplitudes add up. So we are given that amplitude of one of the slits is twice the amplitude of other. The maximum intensity will happen where both the amplitudes will add up. So this will be E1 plus E2. That is 2E2 plus E2. That is 3E2. So this is the maximum amplitude. Therefore, maximum intensity. For maximum intensities, we'll need squares of amplitude. So E square would be 9 E2 square. Now, since intensity depends on the squares of amplitude, so I2 will depend on square of E2. So instead of this equation, we can write I square or I maximum square, or sorry, I maximum is 9 times I2. So this is the maximum intensity. Now we need to find the intensity at a point where the phase difference is phi. So that is, we need to find out the general formula for intensities. So for that we'll have to add amplitudes. We have to do vector addition of amplitudes. So vector addition E at any point. So this is E maximum. So this is E maximum. So let me put an M here. So E maximum. So general E at any point would be root of E1 square at any point plus E2 square plus twice E1 E2 and the angle between them, the cos of angle between them, cos phi. So let's square on both the sides and remove the root sign. So E square would be E1 square, or instead of E1 we can write 2 E2 squared plus E2 squared plus 2 E1, sorry, 2 E2 and cos phi. So I removed the square root sign by squaring both the sides. So this becomes 4 E2 square plus E2 square plus 4 E2 square cos phi. So this gives us 5 E2 square plus 4 E2 square cos phi. So let's get E2 out of this. So E2 square 5 plus 4 cos phi. So this is in general square of amplitude anywhere. Again, we can use this equation here that the intensity is proportional to square of amplitudes. So net intensity at any general point is I2 phi plus 4 cos phi. Now instead of I2 we can write maximum intensity is to 9. So we have to substitute this in this equation, and instead of cos phi we can have 2 cos square pi by 2 minus 1. So let's do these two substitutions in this equation. So we substitute cos phi from here and we substitute I2 from here. So the general equation of intensity is maximum intensity is to 9, 5 plus 4, 2 cos square 5 by 2 minus 1. So simplifying this gives us 5 plus 8 cos square 5 by 2 minus 4. That is, the net intensity is maximum is to 9, 1 plus 8 cos square 5 by 2. So this is the general equation for intensities. Okay, let's see which option is this. So Im by 9, 1 plus 8 cos square 5 by 2. So D option is the correct option. Okay.